Good morning. This is a recording of the 17A Perking Down lab. What we're going to be doing today is to make some models of groundwater and the system that is involving the percolation of water down through the layers of sand, gravel, hard rock, clay. And we're going to be using some cups here that we will create following the directions here. Each cup will be labeled 1, 2, and 3. The bottom layer of cup 1 will be clay, then plaster, then sand and gravel. The bottom layer of cup 2 will be gravel with sand on top, clay and plaster. Cup 3 will have gravel on the bottom with clay and sand and plaster. Some of the terms that we need to know here are the word percolation, involving the seeping down of groundwater through the different layers. We also need to have an understanding of the difference between things being porous and permeable and impermeable. The water that is not going to be passing through material will be sitting on top. And if water comes down through the ground and won't pass any further into the ground, then that would be a description of the word impermeable. If materials have holes in them and water might be able to pass through, that's porous. If there are pores in the material but they're not connected, then that is going to be impermeable. And if you have materials that are porous and have the holes connected and the water can totally pass through, then it's permeable. And so what we're going to do is try to predict if we think gravel is porous, non-porous, permeable, or impermeable, and for each of the rest of these as well. What they would like you to do in this document is to mark an X in the column that you think is going to apply to this layer of material. So go ahead and take a little bit of time to do this. This is part of our hypothesis. How we can predict what we think will happen in this experiment. And then we're going to test it out to see what's true. Okay. So what we're going to do right now is to go ahead and test out our experiment. We're going to move over to this table here where we have some various cups. And I wanted to have us work through this experiment. So I'm going to pour water into each of these cups, and then we'll watch what happens to them. Okay, over here in our first cup with the gravel on top and then the layer of sand, when we look at this cup we can see that the gravel and the sand are very dark colored. That's how we know that the water has been able to soak down in, right? When sand is not wet, it's very light colored, right? So by looking at this, we can see that water has seeped down through the gravel and into the sand. In the second cup, the water just seems to be sitting on top, right? The sand is very light still. We don't see water seeping down in, so the water's just sitting on top of the plaster. Same thing with this cup here, number 3. Look at it. The water's just sitting on top, trapped there. So we're just going to leave them off to the side here for a second. And we're going to look at our page here that we need to fill in. Alright. So on this first one here, cup 1, what it's asking us to do is to watch the layers and record them, the layers that stop the water flow. So what we noticed here was that the water could travel through the gravel. It could also travel through into the sand. Okay, and our document says that we need to do this one, and then we're going to go down and look at cup 2, right? And what we said here with cup 2 was that the water only traveled down through and stopped when it reached the plaster. So it doesn't travel any further, and the same thing with cup 3. It's going to be stopped by the plaster. Okay. Now our directions say to begin carefully by cracking the plaster layers of cups 2 and 3. We're not going to do a trial 2 with our cup 1, so we're just going to put a dash there. But when it comes to cup 2 and 3, what we're going to do is to try to break through that layer of plaster and see how far that the water goes down into our samples. So I want to carefully break down into the plaster here without breaking the cup. And the same thing, oh yeah, that was easy. We'll do the same thing there. Okay, we can see some of the water bubbles here. We know that that means water's going down in. In cup 2, the clay is right below the plaster, and we see that the sand is still dry. So we know that in cup 2, the water traveled through the plaster, and when it reached the clay, then it stopped. Cup 3, we notice here that the water traveled down through the plaster and into the sand, right? The sand is dark colored here, and then the clay seemed to stop the into the sand, and once it reached the clay, it was stopped. Okay, so you're going to use that chart to help you to answer these questions here at the bottom to determine how this relates to a real life kind of water table and groundwater percolation. So what I would like you to do is fill out these. You can use your textbooks and be able to research and try to figure out your answers. Once you fill these out, you can take a picture of this lab and send it to me for your grade. Thank you. Have a good day.